This module provides a review of the hydraulic system. The left hydraulic system operates the components shown here: rudder ratio, yaw damper, elevator feel, stabilizer trim, spoilers, left inboard aileron, elevators, outboard ailerons, rudder, and left autopilot servos. The reservoir supplies fluid to the left engine-driven pump and the left AC electric motor-driven pump. Fluid is supplied from the reservoir to the engine-driven pump through a fire shutoff valve, which is controlled by the engine fire switch. The reservoir is pressurized by bleed air from the pneumatic system.
Low system quantity causes the reservoir quantity light to illuminate amber and displays the ICAS advisory message, left hydraulic quantity. When all fluid is lost, the ICAS displays the left hydraulic primary pump and left hydraulic demand pump advisory messages and the left hydraulic system pressure caution message. Hydraulic quantity is displayed on the ICAS status page.
The engine-driven pump is the primary pump of the left hydraulic system. The pump controls are the engine pump switch and the respective engine fire switch on the fire control panel. Now, the pump is depressurized when the pump switch is off or when the fire switch is pulled. When pump output pressure is low, the pump switch pressure low light illuminates. With the engine not running, the engine-driven pump switch low pressure light is illuminated even if the pump switch is on because the pump is not turning. In addition, when the pump output pressure is low, a left hydraulic primary pump advisory message is displayed on ICAS. An overheat light and an ICAS advisory message of left primary hydraulic overheat is displayed if the engine-driven pump temperature is too high. The engine pump switches normally remain on all the time, except for an engine non-normal procedure. The engine pumps fail to the on condition with the loss of electrical power, so leaving the pump switches in the on position when the aircraft is parked and depowered is normal.
In addition to the engine-driven pump, an electric motor-driven pump provides additional hydraulic power either on demand or continuously during periods of high system demand. A 3-position rotary switch controls the pump. The off position turns the electric pump off. Off is normally selected when the aircraft is parked. The left electric demand pump is inhibited on the ground during engine start to reduce the electrical load when only one electrical generator is operating.
The on position activates the electric pump for continuous operation. On is not selected for normal operations.
The auto position provides additional hydraulic power, either on demand or continuously, for periods of high system demand. The demand pump also provides a backup hydraulic power source to the system when the engine-driven primary pump pressure is low.
Electric pump indications of low output pressure and overheat conditions are the same as for the engine-driven pump, a pressure light and an overheat light. ICAS identifies these conditions respectively as left hydraulic demand pump and left demand hydraulic overheat. System quantity and pressure is displayed on the ICAS status page. Low system pressure is indicated by the system pressure light and the ICAS caution message of left hydraulic system pressure. Note that these indications are for the overall system pressure and not for the output pressure of a specific pump. The right system operates the components shown on this frame. The operation of the right hydraulic system is identical to the left hydraulic system. All switches, indicators, and ICAS messages are the same, except they're for the right system. Recall the center system operates the following components: tail skid, flaps and slats, hydraulic-driven generator, landing gear, nose wheel steering, yaw damper, elevator feel, stabilizer trim, alternate brakes, spoilers, left and right inboard ailerons, elevators, rudder, and center autopilot servos. The center hydraulic system has 4 available pumps. The pumps consist of 2 electric motor pumps, an air-driven pump, and a ram air turbine, or RAT. The center system is normally pressurized by 2 electric motor pumps. Each electric pump is powered by a different AC electrical system.
An air-driven pump is powered by bleed air and normally operates during periods of high demand, for example, landing gear retraction, to supplement the electric primary pumps. If both primary pumps were to fail, the ADP would operate to provide a backup source of center hydraulic pressure. A ram air turbine is driven by airflow and can pressurize the center system when no other pumps are available. Upon dual engine failure and without available AC power, the RAT provides pressure to the center system, but only to the primary flight controls portion of that system.
The center reservoir is similar to the other reservoirs. It has a quantity light to indicate low fluid level.
In the event the center hydraulic system develops a leak in the supply lines, fluid from below standpipe level is plumbed to supply the center number 1 electric motor pump.
The 2 electric hydraulic pumps provide the primary power for the center hydraulic system. 2 switches labeled Electric 1 and Electric 2 are used to control the pumps. When the aircraft is parked, these pump switches are normally off. Both of these switches are normally switched on before engine start. When only one electrical power source is available and both center motor pumps are selected on, the number 2 pump is inhibited to reduce the electrical load. Therefore, with both pump switches selected to on, the number 2 pump will show a pressure light until a second electrical power source is made available. Well, as you know, the alternate brakes receive pressure from the center hydraulic system, and the C1 pump receives fluid from below the standpipe level of the center reservoir.
If quantity is sensed low in the center system reservoir, isolation valves automatically closes to direct the C1 pump to only pressurize the alternate brake components and nose wheel steering. This automatic isolation provides reserve brake operation through the alternate brakes on the 767. If the center hydraulic system fails to automatically configure to provide pressure to the alternate brake system, a brake source light illuminates, requiring the flight crew to select the reserve brakes and steering switch. This action manually configures the center hydraulic system to supply hydraulic pressure to the alternate brake system and nose wheel steering system, and extinguishes the brake source light.
Maintenance controls for the reserve brakes and steering isolation valve are on the accessory panel. The Reset Disable switch is used to reset the isolation valve if it is closed or otherwise cause it to be open. The normal position allows the isolation valve to operate as described and is used for flight operations. The isolation light illuminates white if the isolation valve is closed.
An air-driven demand pump provides additional hydraulic power, either on demand or continuously for periods of high system demand. The demand pump also provides a backup hydraulic power source for the electric motor-driven primary pumps.
With the ADP or demand switch in auto and air pressure available in the center pneumatic manifold, the air-driven pump operates when both center electric pump pressures are low or when heavy load items are selected. This pump switch is normally selected to off when the aircraft is parked and is normally selected to auto just before engine start. Well, you've learned that with auto selected, the ADP operates automatically upon failure of both left and right AC systems. In this situation, the ADP provides the pressure to operate the hydraulic-driven generator, or HDG, for continuous supply of electrical power to essential components. You should know that when the ADP is providing pressure to operate the HDG, the hydraulic fluid supply to the flap actuators is reduced to maintain sufficient hydraulic pressure to the HDG. Therefore, in this situation, the hydraulic flap extension or retraction speeds will be reduced.
In case of rat deployment, only the rat switch press light illuminates, indicating the turbine pump is delivering hydraulic pressure. All other center system indications will continue to display low pressure when the rat is the only pressure source for the center hydraulic system. The automatic deployment feature of the rat is shown as failed to demonstrate manual rat deployment. The rat manual deployment is powered by the hot battery bus, so it is always available if there's battery power. Once deployed, a minimum of 130 knots must be maintained for adequate hydraulic pressure output. The pressure light illuminates when there is adequate hydraulic pressure. When the rat is deployed and operating, both an amber unlocked and pressure lights are illuminated in the rat switch. All other center system indications will continue to display low pressure when the rat is the only pressure source for the center hydraulic system. Finally, you should note that automatic rat deployment is inhibited below 80 knots at taxi speeds and below in order to keep the rat from deploying after engine shutdown at the gate. The inhibit is a function of the air-ground logic tilt switch.
Center system quantity and pressure are displayed on the ICAS status page. Low system pressure is indicated by the system pressure light and the center hydraulic system pressure caution message. Note that these indications are for the overall system pressure and not for the output pressure of a specific pump. The ICAS messages for the center hydraulic system pumps are slightly different than those for the left and right system pumps. The overheat message for the center system primary pumps does not display the word primary. Instead, these messages display as center hydraulic 1 overheat and center hydraulic 2 overheat for the number 1 and number 2 primary electric pumps respectively.
The ICAS message for overheat of the ADP is center demand hydraulic overheat, since the ADP is the demand pump of the center system. Note, the ADP is selected on only during non-normal operations when the C1 and C2 electric hydraulic pumps are inoperative.
The message for low pressure of the center system primary pumps are center hydraulic primary 1 and center hydraulic primary 2 for the number 1 and 2 pumps respectively. The ICAS message for low pressure of the center ADP is center hydraulic demand pump. This completes our description of the Boeing 767 hydraulic system.